Next we're going to look at exercise number 9, taking the limit as t approaches 0 of e to the t minus 1 over t cubed. So again, with any limit, our first option to try is direct substitution. So we'd get e to the 0 minus 1 over 0 cubed. And of course, e to the 0 is 1. So we'd get 0 over 0. So that's an indeterminate form that allows us to use L'Hopital's rule. And again, very important that you'd show all of that first few steps there, that it's okay to use L'Hopital's rule. So L'Hopital's rule says that the limit as t approaches 0 of this original ratio, e to the t minus 1 over t cubed, is equivalent to the limit as t approaches 0, so you have to write the limit notation again, of the derivative of the top over the derivative of the bottom, or the ratio of derivatives. So the derivative of e to the t minus 1 is e to the t, technically minus 0, and the derivative of t cubed is 3t squared. So notice, we're taking the derivative with respect to the variable that's in the limit. So the limit is as t approaches 0, so we're taking our derivatives with respect to t. And now we would try direct substitution again, and we'd be looking at e to the 0 over 3 times 0 squared, or 1 over 0. So this, again, is a limit that does not exist. Might not be clear whether this is maybe going to positive infinity or negative infinity, but if you think about it, so e to the t is approaching 1, 3t squared is getting huge. I'm sorry, that's not true. 3t squared is headed towards 0, and there's no negative values anywhere here, so this should be going to positive infinity. But again, we could do a technology check and look at the numerical viewpoint. Whoops, let me spell viewpoint correctly. So again, I would encourage you to do this kind of check with your calculator or potentially in Mathematica. And if you're using your calculator, make sure that you enter everything correctly. Of course, in the calculator, we have to use x as our input variable, but that's the way it would be entered in your y equals. And here, t is approaching 0 means we have to come in towards 0 from both the left and the right, so we could let, in the calculator, x approach 0 from the left side, and then the way I tend to do it, because remember your calculator can only show 7 values in the table at once, is I would let x approach 0 from the left going down, and then coming up let x approach 0 from the right. And what you should see is in either direction the outputs are increasing without bounds, so they're becoming infinite, which again we could write that the limit equals infinity, and that's correct, but just keep in mind that that means the limit actually does not exist, so we could write dne as well. Okay, then we have number 12, and again I took a little space here. This is an equal sign where I'm doing direct substitution. That's my first try on any limit. So I'm going to do 1 minus the sine of pi over 2 over the cosecant of pi over 2. Remember, cosecant is 1 over sine. So we have here 1 minus 1 in the numerator, and we have the cosecant of pi over 2 is actually 1, because the sine of pi over 2 is 1. So in fact here we have 0 over 1, which equals 0, and we never have to use L'Hopital's rule. No L'Hopital's rule. So again, just a reminder, first thing you should do is try direct substitution and show your work for that. And if you don't get one of those indeterminate forms of 0 over 0 or infinity over infinity or 0 times infinity or infinity minus infinity, if you don't get one of those indeterminate forms, then there's no reason to use L'Hopital's rule, and it could give you, in fact, the wrong answer. Okay, now again, if you want to do a little technology check, and you could certainly be creating tables in Mathematica or in your calculator. Again, even though in the statement of the question they were using theta as the input variable in the calculator, we're always using x. Now note to self, the way you have to enter this particular function in your y equals is 1 minus sine x divided by 1 divided by sine x. So remember, there's no cosecant key on your calculator. You just have to do that by knowing that cosecant x is 1 over sine x. Remember that in your calculator, the parentheses for the argument of the sine function are opened automatically, and you have to remember to close them. Now, I also want to give you another option for x approaching pi over 2. Again, here it doesn't say specifically from one side or the other, so we have to let x approach pi over 2 from the right and the left. One way you could do that is when you're in the table, you could say, okay, pi over 2 minus 0.1, pi over 2 minus 0.01, pi over 2 minus 0.001. That is showing x approaching pi over 2 from the left side. And you could also do pi over 2 plus 0.1, pi over 2 plus 0.01. Since pi over 2 is not an exact decimal, I'm just showing you another technique you could use. And so these, if I just split this up here, these are showing x approaching pi over 2 from the right side. And what you should see is the outputs approaching 0 either way. Okay, so we found that this particular limit is 0, and we didn't need L'Hopital's rule to do it. We could just use direct substitution, and it worked just fine.